Hey Super Scientists, we're looking at your energy EOG review sheet and we're going to be comparing renewable energy and non-renewable energy. So we're starting with renewable. So some examples of renewable energy are going to be solar, which you know your STEM, sol, S-O-L means from sun, wind, geothermal, your STEMs, earth, and heat from the earth, biomass, bio refers to life, and then hydroelectric, hydro refers to power. So you've got STEMs in each one of these that should help you to be able to remember. Then non-renewable energy is going to be from a couple of different sources, primarily from fossil fuels, which is going to be coal, petroleum or oil, and natural gas. And then the other example of non-renewable energy is going to be nuclear, like nuclear power plants. So what is renewable energy? We're going to start with looking at some examples of renewable energy. So renewable energy is going to be replaced as quickly as it's used. So renewable energy is going to be potentially infinite. Hydropower is an example of renewable energy. So that is energy from moving water. An advantage of hydropower is, again, potentially infinite, as long as the water is continuing to be cycled through at the turbines. And disadvantages is that it can cause damage to ecosystems. And that is because if you have a dam that is built, then all the water backs up here, creating a reservoir, but this area past the dam is not going to have water going through. So that can cause areas to dry up. Biomass. So biomass is energy from living material. So energy from living matter, like poop, waste, corn, wood. So those are some examples. Advantages of biomass is, again, potentially infinite. It's cheap to obtain those things as well. And then disadvantages is that if it's not replenished, then it's going to be considered non-renewable. So if it is not sustained, then you're going to end up considering it non-renewable because you run out of wood and you're cutting down all that wood to be burned for energy. So if it's not replenished, then it is non-renewable. So if you're gonna use corn crops and burn those for energy, then you have to replace those corn crops. So that's called sustainability. You're replacing it as you use it or as you consume it. Solar is going to be energy from sunlight. Advantages, potentially infinite, as long as the sun keeps shining. And disadvantages, it's expensive to set up. And I'm going to put a little star here and put solar panels. So another term for the solar panels is photovoltaic panels or photovoltaic cells. And so those are expensive. Geothermal, got your STEM, geo, and therm, so heat from the earth. So heat or energy from magma, basically magma chambers. Energy. So energy from magma. Advantages, again, potentially infinite. And disadvantages, they're expensive to set up, but also has to be near volcanoes, magma chambers. So you are not going to be able to use geothermal energy except in certain spots where you have a lot of volcanic activity. And then wind. So wind is using moving air. So generating energy using moving air. Advantages, again, potentially infinite. And some of your disadvantages, the turbines are expensive, and then also could be damaging or harmful to animals that fly. So I'm just going to put damage to birds and bats. Those are a couple examples. So it can harm animals. So that would be a disadvantage. Then we're going to look at your non-renewable energy. So non-renewable can't be replaced as quickly as it is used. And I'm going to put a little star because it takes millions of years to produce them. So that's why it's considered non-renewable, because it takes millions of years to make it. So that's a long time. So fossil fuels are going to be coal, oil, natural gas. And I'm going to put a star beside coal because coal is where most of the energy comes from, burning coal. So in the United States specifically, most of the energy consumption or energy generation is going to be due to coal burning. Advantages, lots of energy. That's why it's used. And disadvantages, pollution, it's non-renewable, so it's going to be used up pretty quickly. And also CO2, global warming. So carbon dioxide is greenhouse gas and contributes to, or is the main cause of global warming. And then your other example of a non-renewable energy is nuclear. And nuclear is going to be energy from splitting atoms. And I'll put a little star here. Uranium is the primary element that is going to be split for the nuclear fission for energy production. So advantages, again, lots of energy. It's not going to produce as much carbon dioxide as fossil fuels. There'll be a smaller amount of carbon dioxide that's released, but you have radioactive material that you're using. So it's radioactive, like meltdowns basically can occur. Think Homer Simpson and the nuclear power plant that he works at. So nuclear power meltdowns are going to be a problem. And also, it can get used up. So then we're going to look at your graph here at global carbon dioxide levels. So this is a graph that I found from NASA, and you can see the fluctuations in the amounts of carbon dioxide. So it's looking at carbon dioxide right here in your y-axis, and then the years before today. So that is starting with 400,000 years on your x-axis. So you can see the different fluctuations as it's going up and down. And then present day, you can see that there's a drastic increase in CO2, and you have the current carbon dioxide level right here. So what does this graph from NASA show? That there's a huge increase in carbon dioxide presently. So it shows a big increase in CO2 levels. So what is causing such a drastic, such a dramatic, such a big increase in the levels of carbon dioxide in the atmosphere? Burning fossil fuels. So burning fossil fuels is what's releasing so much carbon dioxide into the air. How can ice cores provide information about Earth's history? So ice cores are going to show how the atmosphere has changed over time. So ice cores show how the atmosphere has changed over time, because the ice cores, as the snow and ice is deposited, is going to trap gases and particulate matter from the air. And also, they're going to show one of the main things is that the ice cores are evidence for the carbon dioxide levels having increased dramatically over time as well. So we're going to be able to see an increase in CO2 levels in current ice. And then your last question here, conservation. Conservation involves preventing the loss of a resource by way of thoughtful management and use and consumption of the resource. Increased human consumption can have long-term consequences. Since the Industrial Revolution, which you may have talked about in social studies, human activities have resulted in major impacts on air, water, and soil. Pollution has cumulative ecological effects like acid rain, global warming, which is also called climate change, and ozone depletion, so depleting the ozone molecules in the atmosphere. And we know the ozone is in the stratosphere and it protects us from the sun's harmful UV radiation.